Welcome to the first webinar of PDM Analysis Limited for this Ranking 2020 conference. And this webinar is about CFD analysis of twin screw machines. In today's webinar, we will introduce presenters, talk about SCORG and CFD analysis a little bit, tell something about features, and show you some applications for expanders and other machines. Today's presenters are myself. I'm Professor Ahmed Kovacevic from City University of London, and I'm Director of PDM Analysis, and Dr. Sham Rane, who is a Senior Research Fellow at City University and one of the main people in PDM Analysis who is developing SCORG. PDM Analysis is the company that was spun out from City University of London in 2014 to exclusively license and develop SCORG software that we started and developed at City University from late 1990s, and then firstly commercialize it from City University. And then from 2014, we are commercializing, City University is commercializing that through a company called PDM Analysis, who we represent today. SCORG is the unique software for design and analysis of positive displacement machines, including screw compressors, expanders, and pumps, internally and externally geared machines, vane compressors, expanders and pumps, roots blowers, gear pumps, and some other machines. And it is used for CFD analysis, thermodynamic analysis, and some other means of analysis of these machines. The structure of SCORG is shown in this slide, and on the left-hand side you can see modules which are basically profile and geometry analysis module, thermodynamic or lower order chamber model, and then a module for 3D CFD analysis of screw machines. The first module is used to import or generate profiles, and importing or profiles could be from a data file or from a CAD system. And then it is used to set up the machine as you want it to be, and to calculate chamber volume, areas, and other important elements which are required for second thermodynamic chamber model. Thermodynamic chamber model could be run internally in SCORG or by some other software, which in this case this is a GT Suite, so it could be either internal or external thermodynamic model to calculate gas pressure and temperature, leakages, power flow rates, forces, and obviously boundary maps that is later used for CFD analysis and finite element analysis of the machines. And then the latest model, which is a CFD module, is for grid generation of meshes for screw machines, and then pre-processing to be used for variety of CFD solvers like Cimerix, ANSYS CFX, and Fluent, Star CCM Plus from Siemens, and OpenFOAM. And I will now hand into Sham to talk about in more details about CFD modeling using SCORG.
The CFD modeling consists of a solution domain, which is a representative of the problem that we are solving. And in this case, which is to do with compressors or expanders, it basically consists of different domains. For example, what you see here is a suction port, which is aligned here, and a discharge port, which is here. And in between the two domains is the main deforming chamber, which is the rotor domain. Because these are positive displacement machines, the rotor domain deforms with time, and the enveloped volume between the lobes of the rotor squeezes in order to decrease its volume. In addition to these common domains, you can also have, depending on the design of the machine, some liquid injection such as oil or liquid refrigerants. The biggest challenge in the 3D CFD modeling of twin screw machines is how to generate the computational mesh for the rotors. And Scorch is a unique software tool that enables to generate the mesh by using the rotor profiles as the base and then some parameters which can be defined to control the size of the mesh and its structure. In this particular example, what you see is a structure called as single domain conformal mesh, in which case the grid which is enveloping the rotors remains fixed in space, as you see here, and there is no interface in between the two rotors, thus ensuring highest accuracy of the flow solver. Additionally, the leakage volumes in terms of tip leakage, interlobe leakage, and the blowhole areas are accurately captured within the grid generation. On top of this, you can also have the end leakages, which can be the axial faces and can be generated through external grid generators. Once the rotor grid is generated, it is connected to the ports into the solver, and then we go into the solution. In terms of CFD solution, several solvers are available as options. Scorch grids are readily connectable to ANSYS CFX, ANSYS Fluent, Star CCM Plus, Cimerix MP, and the latest in the line is OpenFOAM solver. In this particular example, you can see the pressure solution on the surface of the rotor, and it is a compressor, so you can see during the discharge the highest pressure is seen. In the discharge port, you can see the flow velocity vectors, which represent the pulsation occurring in the port, and also the dynamic losses associated with non-uniform velocities. This example is of a twin screw expander running with R245FA and R134A fluids. Within Scorch, the geometry module allows you to calculate the chamber volume, as you can see here, and also the inlet and the exit areas, which can be used to generate theoretical ports. So in the initial design phases, when you don't have the real geometry of the expander, you can work with theoretical ports and built-in volume index can be set as per the design. In this example, we have used different equation of states such as the Peng-Robinson, Redlich-Kwong, and Sauber-Redlich-Kwong. And in addition, also the RefProf database can be coupled directly with the flow solver in order to see the accuracy of the solution. A grid, typical grid in the cross section of the rotor is shown here. This is the male rotor and the gate rotor. And as you can see, the nodes are connected one-to-one between the two rotors, which is an example of a single domain conformal mesh. It's quite unique to Scorch as a grid generator, and it enables a robust solution, enabling good stability of the solver and also giving a high accuracy of flow and power estimates. Here you can see the results of pressure distribution using RefProf fluid for R245FA, and this is the temperature distribution. In pressure, there is a lot of uniformity within the chamber, but you can see it is not the case with temperature. Due to leakage flow and non-uniform temperature, it can be accurately captured using the CFD model. There are some advanced examples such as oil-injected compressors, as you can see in this video. The oil is treated as a secondary phase, and the gas of compression is the primary phase, and the whole solution is solved using two-phase Euler-Euler solution. This particular example is from the ANSYS CFX solver. Here you can see some non-conventional rotors such as variable lead type, where there is a larger lead on the suction end and a lower lead on discharge end, or a conical rotor. So these designs are not yet available in manufacturing, but they can be easily computed using Scorch grid generator. Similarly, you can have a dual lead rotor, or some external gear pump examples could be solved. Furthermore, you can explore variety of configurations such as multiple gate rotors, multiple screw machines, internally connected twin screw rotors, as you see in this example, or a different type of machines such as vane compressors and expanders, as you see here. And the latest solver which we have integrated in Scorch is the OpenFOAM solver. The advantage with OpenFOAM is that it is a open source code, and then you can directly use it with Scorch grids through the user routines which are available with the solver. The examples which are presented here are root floor and twin screw compressors. Thank you.